Morning. Um, so for the Ontology Working Group, we're going to do something a little different than we've done in past years, where we just kind of review what we worked on for the previous year. This year, what we're going to do is kind of share some. It's too loud. We're going to share some community ontologies and some examples of other ways that you can look at your data, aside from like what we usually do, just the enact ontology. And we'll see some new data that some of the community members have worked on, and hopefully get your juices flowing to show you how helpful an ontology can be. So these are the members of the Ontology Working Group. They are a great, helpful group of people, and I give them credit for helping me do all this. So what is an I2B2 ontology? Because it's not a technical real ontology, because it doesn't represent all the relationships that an ontology usually does. It's mostly a hierarchical concept tree that lets you either use path-based logic or custom SQL to connect to the facts and observation fact table. The nice thing about an I2B2 ontology is very flexible, and you can have multiple representations access the same facts, but look at them in a different way, different classifications. Like in the enact ontology, we have both a medication ontology that is organized by alphabetical ingredients, or we have a medication ontology that's organized by a VA classification, like statins and things of that nature. And they both work off of the same facts. The I2B2 ontology is also really good for emerging use cases like COVID, where there's new concepts and new codes, or maybe they don't exist. So you can put them in your own local things and then go back and change them later. So, like I said, we're going to do same data, new lens. I'm going to do that part. And then these guys are going to do new data, new lens. Same data, new lens is, I want you to kind of think about different ways that you can look at your data. So the traditional data that's in most of our I2B2s are EHR data, your labs, your meds, your diagnoses and procedures. So we have a few ontologies that in enact, I put them under a research folder, and to be able to look at that data in multiple ways. And I will also look at COVID ontology, which is a different type of ontology. It's more disease focused. And then of course our OMOP ontology. So this, I don't know if you can see this, but this is a example of how you can look at a single code through multiple ontologies, accessing the same data within your system. So this is I10 and ICD-10 CM code that for essential hypertension. For in enact, we basically have it under an ICD-10 hierarchy, which uses that classification system to access the code. But it's also in comorbidities ontology. It's in, we have two comorbidity ontologies. We have Charlson and we have Elixhauser. So you can access the code via that ontology, which is a different representation, a different hierarchy that would actually include that code. We also have, we've included the fee code ontology underneath the research ontology. And that one, you know, I10 is underneath one of the fee codes, under I think 401 or something of that nature. So, and then lastly, at Pitt, we're working on a side effect ontology where we're trying to link MedDRA side effects to EHR data. So that would be another example of how you could get at that same ICD-10 code from multiple different angles. It's good because you can use it. So say you were doing some research on a cohort, and you wanted to compare like different treatments for that same cohort, you would be able to use like the Elixhauser comorbidity index to kind of look and see, you know, if I'm treating with treatment A versus B, how do the comorbidities in those groups look differently? They're also really good for, a lot of people do their research using fee codes. So they're good for rolling up data to higher level concepts. So you're not just dealing with specific ICDs. You can roll them up to the fee code, which has a more, a collection of ICDs to represent a given phenotype. And then like with the medication side effect, you would be able to do breakdowns using those.
Michele, is there an explicit statement about which version of fee code table you're using in any of these? So we have, if we get an output from it, we know there's a metadata attribute to it that says version X.
I believe it's in the
code table.
comment in the actual ontology, but I don't know it off the top of my head. So I could
that would be
definitely.
anytime we get an output from that, we want to know version
Okay.
that it was compiled against.
Yeah. Yeah.
And
yeah.
what happens when you do a fee code update or, or a...
So right now we're just, for ENACT, we're just updating the ontology once a year. So, and in the comment, you should be able to see like the version of the source information that I use. So it'll tell you like UMLS 2025 AB.
Where's the comment field appear?
The comment field is actually in the metadata table. So give me a second and I might be able to help you a little bit more. All right. So this is just an example of using, there's multiple ways to use breakdown queries. You can use custom XML, which is a newer feature, but the old way that you can create breakdowns is to use an ontology. So basically you tell it a top level and it'll take that first level of the tree, run all those queries to get the frequencies for your given cohort. So having ontologies is helpful in that respect. It makes it easy to make breakdowns. Another ontology is a disease-focused ontology. And I mean, I'd like to use those more because what you're able to do is like include expert knowledge into the ontology for a given disease. So when we did COVID, we were able to like create small phenotypes to determine whether or not it was a patient who was moderate or severe. And there's other expert knowledge in there that is like the medications that are specific to COVID, which would make it easier for your researchers to get at information they may not otherwise know. And this type of ontology would have mixed domains, whereas most of my other ontologies are single domains, like just ICD-10s or just ICD-9s or just CPTs. This type of ontology has a mix, so you will have diagnoses that are related to your disease of interest, your procedures, your meds, your labs that are all related to your disease of interest. And then the last one is using ontologies to access non-I2B2 data. My example of this is the OMOP ontology. So basically underneath the data source for this ontology is actually an OMOP database. In this case, you can use the I2B2 multi-fact table feature to basically what happens is you're transforming the OMOP data into a view that looks like an I2B2 observation fact table, and you're using the multi-table feature to access the different tables. So when you run a query using multi-fact, you can tell it, look in this ontology, and this ontology to find the concept, this table. So when you have a lot of tables, you can do that. So those are the examples for that. And now we are going to move to new data, new lens. And we're going to have some examples from Mark, who's formerly with USC and is now a consultant on his own. And then I am going to present Twee from Ochin, prepared some slides for one of the use cases that actually that keynote speaker talked about yesterday. They actually have an ontology and answer that use case. And we'll have Mike from Mayo. So take it away.
Good morning. My name is Mark Abajian. Abajian Consulting, formerly with USC, University of Southern California. I'm here to talk to you today about the SEDOH ontology. We call it SEDOH, S-E-D-O-H. That's Social and Environmental Determinants of Health. And as Dr. Burrell yesterday was discussing how it's important to have socioeconomic and environmental information about your patient database, then this is something that we addressed several years ago, preparing an ontology and a toolkit. Just about myself, I want to say that I've had over 30 years in software development, in informatics only the past 8 years. I volunteered with the Ontology Working Group since 2024, and I was with the Data Harmonization Working Group with ACT for a couple of years before that. I was with the Clinical and Translational Science Institute at USC, and this is where we developed this ontology a few years ago. So, oh, here we are, okay. So, so here we are, social and environmental determinants of health. It's actually 32 measures of social and economic determinants and 6 measures or more of environmental information. This was developed by my former team under Dr. Daniela Meeker, who was a professor of clinical research informatics, and Dr. John Wilson, who is with the geospatial department at USC. And we published a paper in 2023 calling it Sunday. It's this SEDOH ontology plus a toolkit for creating this data, adding this data, enhancing your database, your patient database with the SEDOH data. And there's a toolkit involved in this because there's 2 things that you have to grab from the internet when you're building this. And it is the data that can be applied to all patients. And the other thing is you have your patients' home addresses, and you need to be able to geocode those addresses, match them to census tracts, and then apply the data that's appropriate for the census tracts. And so that's why there's a toolkit that goes along with this ontology. So the motivation for this was that there should be some way to examine our patients' exposures to social and environmental factors via I2B2. And so this is patient-specific exposure data. These are not diagnoses. This is not patient-reported. This is objective information. It's precise to a census tract level. And the data are reliable. It's published by civic agencies and by NGOs. And it's accurate as long as you have accurate data on your patient's residence addresses, then you can match it up with the census tract through geocoding. And researchers can, with this information, infer causality and see trends in the patient database. So where does the data come from? These 32 measures, socioeconomic measures, and the 6 or 8 environmental measures that we have, they mostly come from the American Community Survey, which is published by the US Census Bureau, 29 measures of race, ethnicity, education, income, housing, etc. The US Department of Agriculture provides us with 2 measures of food accessibility. The Centers for Disease Control provides something called the Social Vulnerability Index, or SVI, and that's based on 15 different socioeconomic measures. NASA provides us with data that are 2 measures of air quality. And we have California air quality measures also from the California Environmental Protection Agency. So here's a picture of the ontology tree. This was produced in 2021. This is how it looks in the current demo version, which happens to be online. I'll give you a link to that later on. There's some comments at the top that are in red explaining how to use this particular data set. And then you see a number of items there. If I can, I don't know if it, can you see me mouse over this or not? Maybe not. Okay. Anyway, we have alcohol accessibility. It's a number of liquor stores per 100,000 population. Drinking water quality. Again, this is not information that is reported by the patient. This is stuff that comes from government agencies, and we assign the values of where the patient is living in that census tract. What was the measure for the people living in that vicinity? So we have some other measures here: ethnicity, food, housing, income, some social indexes, race. When it says race, it's not the race of the patient, it's the percentage of different races that live in the geographic region where the patient lives. So a URI for where are these entries coming from? As I said, these are not ICD codes because those are diagnoses for individual patients. This is an independent ontology that we developed using information from the American Community Survey mostly, and as I said, NASA, USDA, and CDC. I'm sure that it's in our toolkit, the URIs for these would be in our toolkit because our toolkit goes out and fetches the data from these URIs. There's APIs that the toolkit utilizes to pull in these data from those sources. Okay. Let's see, so now I'm going to switch gears a little bit because there's something else that Michele wanted me to talk about, and that is something that strikes fear in the hearts of us programmers, but no, it's just called metadata XML. And what is metadata XML? You'll find this in the ontology database. It's XML encoded into the ontology or metadata table. That's why it's called metadata XML. What do we do with metadata XML? Well, we're using it specifically for every item that's in our pseudo ontology, but it's used mostly for measurements like labs and vital signs, and allows you to query for specific values that your patient might have in the database. There's also multiple units allowed, and I'll explain that in a moment. Here I'm giving a close-up of some different air quality measures from our ontology, and so I want to focus in on this one, ozone. You might be interested in patient health, for example, if you have asthma patients, you're interested in what kind of ozone exposure is there in the neighborhood where they live. And so here's another thing that's a slight digression, but when you mouse over this item in the ontology, you get a tooltip. And the tooltip explains exactly where each ontology item came from. This ozone came from the California Enviro Screen, which is California EPA. The bottom line of the tooltip tells you that the values in our databases range from 0.03 to 0.07 parts per million. The EPA standard for what's considered high ozone level is 0.07 parts per million. Let's say that I'm interested in finding out who lives in an area, a census tract area that has high, oops, there we go back, that has high ozone. So when you drag that ozone concept from the ontology list, ontology branch, drag that into the query panel, then this will pop up. This is a modal window that pops up and allows you to enter a value for your query. So for example, it's asking you choose a value for your ozone. And as you see in the middle of that, it says greater than or equal to some number. And I put in the number 70. Now the options besides greater than or equal to are greater than, less than or equal to, not equal to, and between. You can set a range of numbers that you might be interested in. And so these are the different options for numeric values in the pop-up that's related to metadata XML. In this case, I put in 70. Why 70? Well, I'm interested in parts per billion, not parts per million. So if you go down at the bottom of this pop-up, you see it says, kind of small, but it says ppm, which is the standard, but there's also available in parts per billion, ppb. And let's say I'm interested in that, I can use those units instead. So these are options that can be coded into your XML if you're interested in giving additional options for units. So thank you for letting me digress into the metadata XML. Let's move on now to use cases for our pseudo ontology. So one use case is cohort recruitment. At USC, Professor Zhanghua Chen, who is an environmental epidemiologist and biostatistician, has been using the pseudo ontology since 2022 for cohort recruitment. She, I believe she, is using I2B2 and RedCat platforms and using these social and environmental exposures to do her query, do her cohort discovery. Use case number 2 is something called an asthma risk score. Now, this is developed by a colleague, Dr. Juan Espinoza, who worked closely with Dr. Daniela Meeker at USC. He's also, he's associated with USC. He's also associated with the Children's Hospital Los Angeles and their innovation studio. At Children's Hospital Los Angeles, he is using the M-Page platform in Cerner and adding an environmental risk score, an asthma risk score, to each patient. And so clinicians can see this. Let me show you what that looks like. He's been using this for several years now. So the asthma risk score shows up in this Cerner M-Page to the clinician. You see on the left there, patient's asthma history, and then there's environmental risk score and a social risk score. And these are based on certain measures from CEDO that are listed down there. There's 4 measures for environmental risk and 5 measures that went into social risk. So recent updates on the ontology. This was originally published in 2023, and since then at USC, they've been working on a CEDO API wrapper around the Sunday toolkit. And the goal is to be able to get weekly updates of this data coming in from the different agencies, use all the patient addresses, historical addresses as well, and update this information for all patients. They've also developed or are developing Z-scores. So they go into their database for each patient and each of these measures, they assign a Z-score that describes basically how different each patient's score is based on their census tract area, how different their score is than the average among the entire USC population. And they're also interested in adding these measures to their electronic medical records. They're especially interested in getting food insecurity scores for their patients with diabetes. So here's a list of resources. I'm not going to go through each one, but you can view this slide later on if you're interested in any of this information. And the point of contact at USC is Praveen Angyan, a former colleague of mine. If you have any questions about this, please reach out to me, or you can visit me. The same list of resources appears on my website, abanjanconsulting.com. Thank you very much.
Okay, so I'm going to present for Thuy. She's from Ocean, and she's a data engineer. So Ocean is a nonprofit healthcare innovation network that supports community health organizations across the United States. It provides shared technology solutions, including a single instance of the Epic EHR, along with data, research, and consulting services designed to improve access to high-quality, affordable care. They house one of the largest, most comprehensive community health data sets in the country, and they have 8.1 million patients from 286 health systems and 2,200 healthcare delivery sites across the U.S. The SDOH ontology that they built speaks directly to the use case pointed out yesterday by Dr. Burrell, is that her name? So they use it to do screenings and capture patient-level information, which is different from Mark's example. Their patient-level screenings are collected during clinical encounters in Epic, and it contains structured and unstructured data that they put into 3 buckets, negative, positive, and not applicable. And the domain availability for the questions vary by site since they're in all those different healthcare systems. The reason why they did the bucket system, so basically they evaluate the survey data and put it in the buckets so that they can use this buckets to determine what patient needs are needed. I guess that sounds funny. At a population level, and then be able to identify individual patients that have unmet social needs that are impacting their health. They also, which was another part of the use case, use it to support care coordination and referrals within their system. And they look at things like child and family health care, financial strain, food insecurity, and all the regular social determinant of health. Okay, so now I will give it to Michael.
Thank you, Michelle. So my name is Michael Lin from Mayo Clinic. So, oh, somebody edit this slide for me. Let me see. Okay. All right, maybe I'll first talk a little bit about our I2B2 instance at Mayo Clinic. We have a single instance for the entire Mayo enterprise, which comprises of the 3 major sites and probably 50 different small clinic hospital that we call the Mayo Clinic Health System. So the access to our I2B2 is really open to the entire Mayo Clinic staff, not just to the research. And this may or may not be somewhat unique, is that our I2B2 actually are used to support both research and the practice use cases. And we have about over 11 million patients with data dating back as early as mid-1980s. And most of our I2B2 data is sourced from our enterprise data warehouse. And as I talked about a little bit yesterday, we do have some data from Clarity, very small percentage, and also other resources. And both due to user feedback and also for necessity, we have moved to an incremental daily data refresh a few years ago. So what is Tapestry study? Anybody here have heard about Tapestry study from Mayo Clinic? Okay. So this is a very large-scale study started back in 2020 with an enrollment target of 100,000 participants. And the idea is to perform a whole exome sequencing for all 100,000 participants. And so Mayo partnered with a company called Helix to do that. And the purpose of our Tapestry study is both clinical and research. They're going to use these sequencing data to help predict patients that may have certain undiagnosed disease or conditions based on their variants. But also, this is building up a large data sets to support future research users. So the consent form is structured in such a way that the patient is aware that, or the participant is aware that their data will be used in such a manner. So let me talk a little bit about ontology. So to me, the flexibility of ontology in I2B2 is a real strength. It's pretty straightforward and quite frankly, easy to implement. Tapestry is actually the second study that we have done. We have also done this for Biobank. The Mayo's Biobank study, which comprised of about 57,000 participants. And in both cases, it's actually the PI reached out to me and wanted to put their data into I2B2. So, and I'm probably not gonna follow all the bullet points here, but I want to make sure that I cover everything I wanted to discuss here. So, in both cases, even though they both are research studies, they have very different use cases in mind. So we structure the ontology based on the use cases. So the process is that my team, my I2B2 team, met with the study team and with the PI and make sure we understand what's the intended use cases. And then we then structure the ontology based on those discussions. And I would say that discussion actually probably take more time and effort than when we actually implement the ontology. Such is the ease of making a new ontology in I2B2. And we also have ontologies that in I2B2 that are not study based. And which is, I would just say that like we added a patient's future clinical appointment ontology into our I2B2, which is very popular because it helped with the recruitment effort significantly. So, and one of the main reasons for Dr. Lazarado, the PI of the Tapestry study, to want to put the ontology into I2B2 is that he wanted to be able to associate participants of his study with their medical data easily. And so I2B2 is perfect for that purpose. Okay. So I'm going to talk a little bit about the nuts and bolts about how we do this. As I said earlier, we developed a simple ontology in collaboration with the Tapestry team to meet their needs. So I'll go back to the previous slide here. You can see that on the right-hand side, that's the Tapestry ontology that we developed. And to get the data populated, my team regularly receive a file from the Tapestry study team in the format that we agree upon. And I believe that we started out doing a monthly import, but since this study is actually reached their enrollment status 18 months ahead of schedule. So since then, that I think we changed the interval now to maybe quarterly or maybe even longer. Okay, and here's another thing about the flexibility of ontology. I mentioned there's another study called a biobank, and then there's the Tapestry study. And they have different requirements and governance over the use of their data. So at Mayo, we actually developed our own data export plugin, and also the participant re-identification plugin. Okay. So I believe in the Tapestry's case, we started out is that we were able to build in rules. Let's just say if you are a user and you pull in a Tapestry participant in your query, and you can export their data, or you want to re-identify their identity, we actually have to first check to make sure, are you on the study roster of certain IRBs? And if so, then you are allowed to proceed. Otherwise, we ask the user to go back to the study team and to get their permission. Okay. So this can be done in different manners. But since then, we have these sequencing data available. And of course, we don't store the sequencing data in I2B2. We have added another feature is that if the user wants to access the sequencing data, there's a pop-up message when they do their data export or re-identification. We advise them to contact the study team to get access to the sequence data. I believe that's my last slide here. Okay, recover project. Go back one. Okay. Oh, I'm the last one. Okay. Oh, the last line. Oh, I'm sorry. Thank you, Michele. So we look at the number of usage over the, I believe it's just the past year or maybe since, since 2021. We have 50 individual query users that have made use of this ontology, and they built over 500 queries with the Tapestry terms. Thank you.
Okay, so our last set of ontologies that I'm gonna quickly go over is from the Recover project. Unfortunately, they are double booked, so now I have to present this. And this is the Recover team, Victor Castro, Nick Watanason, Mike Mendez, Jeff Klein, and Vivian Gaynor. And then if you need more information on the Recover project, I think Victor's probably a good contact. So the Recover project is that giant billion-dollar COVID project. But I wanted to look at their ontologies because it was a good example of non-EHR data-based ontologies. They have everything from Fitbit data, autopsy data. I believe they have some clinical trial ontologies. So I wanted to use this example. One of the other things that came out of doing this project, Niche built a data dictionary, which Griffin talked a little bit about the term info section of the I2B2, but what I believe I'm going to do is use this to be able to give the information that Bruce was asking about. So Niche has made it possible to put specific syntax into the comment section of your metadata tables that you can use to display a data dictionary. So you can see, you can put a section that talks about your REDCap integration or your harmonization variables and a lot of detail about the various things in the ontology. So I'm going to go back and backfit the enact ontology with a lot of these details because people are always asking me for data dictionary information, and now I will be able to provide it. And this is just another example. You can, because that field is a blob, you can put images in. For Recover, they put like code blobs on how you can get data from, I think, this thing called 7Bridges, which is some kind of data access environment that they have within the Recover project. The other reason I thought this was a good example was because this is an example of a REDCap to I2B2 integration. There are two forms of REDCap to I2B2 integration, but this newer product is an ETL using an R package that allows you to asynchronously stage tables and build ontologies to put the data into your I2B2. Victor provided the slide. I don't know all the details, but I thought it'd be good to get the information on paper for later review. I think that's it. So thank you. If you have any questions or comments, or we would love to have you come join the ontology work group, you can contact Mark Cirillo and he'll be able to hook you up. All right.
So we do have some time for
Please
questions from
comment.
the room. And I will say too, just to echo what Michele, you said, in the link, sorry, I dropped a link to the working groups into the chat in the Zoom. There's also a QR code on each of your tables to join the working groups.
Website day?
It is perfect. So yeah, welcome to join the working groups that we have talked about this morning, user interface and ontology. And we've got a few minutes now for questions for any of our
I have a
presenters.
comment I'd like to make.
Sure.
So I wanted to say thank you to Michele for leading the ontology working group, making it very pleasant to join that group and participate. I also want to invite anyone else who has produced a unique ontology at their site to maybe share that with us, and if published or not, if you're interested in sharing, then please let us know at the ontology working group, and we'll be happy to help you disseminate that.
Hey, so from Twee's work, Mark's work, some others, it feels like there's some parts of the ontology that are pure environmental. Like I would put ozone, right? Two houses next to each other are going to experience the same ozone. There are some cases where it's more like social environment, like you live in an area that is of a certain general economic status. It might involve the street you live on or whatever. And then there are things that you're using these factors like typical household income in a census tract to act as a proxy for what is patient level information you haven't directly gathered. It's not quite a diagnosis or a lab, but it's something that if you asked, and I think Twee's work, I think it was Twee, they're actually asking them questions during intake and they're getting specific, this patient is experiencing food insecurity. You're not imputing it because they live in a food desert. They're actually saying, I don't have enough to eat, me personally. Is there any thought to how you can take these ontologies that where you're using the census tract information to impute probable patient values and sort of lay them up against, but if you ask the patient directly, like I live in a food desert, but I have a car. So I can drive 10 miles away and get food. So I don't experience food insecurity because I have transportation, right? And is there a way of like making combined queries where it's like, if the patient has answered the question directly for themselves, I ignore the census tract data because I don't need to impute it because I have explicit knowledge. That kind of notion of mapping the ontologies together.
Ontologies lived in the same I2B2, that would be really easy, right? Because you put in one panel the patient reported fact, and then in another panel you would put the CETO fact, and you would get the intersection of the two. But this so happens that right now these two ontologies don't live together, right?
Right, so there hasn't been a kind of built-in way of saying, this is how you make these comparable. If you, as a researcher, knew they were both there, you could
You could run a query that would get the
There's no kind of, I guess what you could do is build an ontology that's like down at a one but the leaf node, put both the environmental and the individual factor, and sort of say if one exists, use
They're
the other one
ands.
kind of thing.
I think in the ontology, the leaf nodes become ors, right?
Right, so if you went one click up, like there was one node that had, as children, the environmental imputed value and the no.
Build it, right, because your top level says this or this or this, right? So you always have to use the query system to get that and condition.
Got it.
Jake. So you could do the group, but what I'm saying is everything that's a child of that parent becomes a or.
And what you're doing is, I mean, you could be
He
using
wants
a
a and.
subset of the parent if you want, of the ors, but if you've got multiple, it depends on what you're gonna, you know.
It doesn't matter what it is.
You want to group by your parent
You
or
can't put
or a
parent
new
and
sub of
get
the
an and
parent.
situation. You always have to use the query to get the and. Parent always makes an or.
Yes, yes.
There's no real.
But if you
It
want
would
to
be
assert
nice.
the parent that where all of these like childs are included in the parent, then you're going to have that group by parent parameter in there in your.
Yeah,
Now-
I mean, it would make it easier because you could grab it all at the same time, show it,
Subsumption.
but it's just nature of the system. Parent makes.
No, but if we want to make the assertion of, I want to get all the children of this parent, then fine. That's what, yeah, both the parent and all the ors.
Okay.
So I'd like to make one comment on that, and that is that if you have a folder, and inside the folder, let's say you have a folder that says ozone. No, that would be, people don't report their own ozone, forget that. So let's say you have something that says food insecurity. And so there's a patient-reported food insecurity that TWE's ontology may have, the OCHAN ontology, and there is CDC or I can't remember which one it was now. There's,
Yep.
okay, so there's, okay.
So let's say
There
you
might be,
want.
but there might be another food insecurity leaf underneath that food insecurity folder that comes from this other CETO ontology that comes from census tract related data. So there's some concern about if you just use that folder that says food insecurity and you drag that over, you can be mixing different kinds of things because one is patient
It's a-
reported and one is not.
It's an incredibly important parent, but when I'm doing individual case record analyses, I want to know, is this a kid that's dependent on school lunches as its primary nutrition? So I want to assert that as, a really key subgroup. This is a micro subdivision of the macro parent, but it's absolutely critical to understand that kid and that group of kids. How do we do that? Within the SDEOH.
Maybe we can take this offline and improve both of the ontologies that we're talking about.
This is a mission for precision med of course, but we want to leverage everything that you've done in the SDEOH, which looks beautiful.
So I've got a question kind of riffing on that, but kind of from a different dimension and kind of pulling in the pipeline conversation. Is in the ontology, is there good coverage for data synchronization and data sort of quality pedigree as you're building the ontologies? You know what I'm saying? Like, so if you're working between ontologies and you're getting these extracts, right? And how do you ensure that they're synchronized, right? So the patient, depending on the frequency of the batch processing or the overnights and all that kind of stuff, you get stuff kind of arriving at different frequencies. In the ontology, is this all programmatic? Is this all sort of computational that you? Does that question make sense?
Kind of, but I guess like if you wanted all data that was in some date range or whatever, I think you would have to use dates in your actual query.
So
There's
you're sort of
nothing
building
really
it.
in the ontology that says,
Yeah.
there's no real dependency between ontologies. So every ontology is
no meta
unto
ontology.
himself. No, there's not a meta ontology.
yeah.
So you can just keep adding ontology
Yeah.
to
Okay.
your heart,
Yep.
And
they're all sort of locally coherent, locally consistent, but then you have to do all of the synchronization and
Yeah, and I
between,
think
yeah, okay.
the question you're posing probably is not as much for something like an ITB2 that's doing the real-time query, but what you're saying seems to be more like analysis on the back end of the observation facts or whatever.
To kind of bring that dimension into it, so that
I don't know anything.
that's a kind of per case. It's kind of provenance is definitely a big portion of that.
First, I'll make a comment if I understand you correctly. Just like Michele said, sometimes these ontologies come from independent sources.
Yeah.
Really difficult to make sure that the data integrity is there.
Yeah.
Because quite frankly, we have found cases that the data integrity problem is actually not in I2B2, but in the source data.
In the source data, yep.
So what we have done though, since we do this daily incremental data refresh, and I personally thought about this type of question about data integrity from the get-go, because I worry that we are providing the wrong answer to people's question, right? And I would just make a comment to say that one thing we did is that we developed a collection of queries that we run after every single data refresh.
So it's like a regression test.
Yeah, it's kind of a regression test, and it's kind of like a sanity check, if you will.
Yeah.
Does it guarantee data integrity? No, it doesn't. But if we see something really off, then we know we need to look into something.
Yeah.
I know that's not a perfect answer, but yeah, I just want to make that comment.
Sounds like an answer that might work, so.
Michele, anything you'd like to add? Or? All right, thank you. Excuse me? Yeah. And I'll make another comment. You mentioned metadata about ontologies. It's a challenge because you can put a metadata somewhere or that whatever that, but how do you make sure that the user actually go check it? Right? Most cases they don't. So one thing we did is that I can't remember the exact example, but in our ontology, sometimes we put right there on the ontology in parentheses to indicate. I think it might be ICD-10 or ICD-9, the day range. So, yeah.
Actually, in the enact ontology, to have like what the date range, but now we just show whether or not. This obsession. So because it became a little bit too much noise on the labeling. So people were like, no, take those dates. We used to have like the date that the concept came online and the date that it went offline, or if it was retired or still a current concept. But people felt like that was too much noise in the label. So now the section the term info section should show you the range of dates that the concepts are valid. But again, the historical data is still going to have codes that are retired, so we leave all those concepts in. But you will be able to see which concepts are still actively being used.
This is something that like the HubMap group has really done exquisitely well, is where if you make a publication off of the use of the database, and you want to then say on this publication, here's my little package that has the provenance tracking that says version level that this analysis download was performed against, and that's all right there in the data
Nice.
blob that goes with the, the supplementary material or whatever that with any given manuscript at a time.
Cool. I mean, I guess that would be something, I mean, for what we're doing, right? We're just doing like real-time querying. But I guess if you're using the data for analysis, that probably is something that you could connect up to the export, the I2B2 export tool.
I have a question that's orthogonal to previous ones. Multiomics, genomics, that not covered today. I was wondering, is there any update on that? Or
For that, you probably have to ask the I2B2 team. They utilize those features way more than I did. And yours is more of a reference to the genomic data. Yeah.
yeah, another question. Which
I don't know, Nick knows a little bit about some of the genomic representation within I2B2.
of genomics. Yeah.
Sorry about that, but I would say that the ontology that's currently in there is dependent on the ingest pipeline. There's an example ingest pipeline that gives you some simple ontology such as loss of function, premature stop codon, whether it's a synomic mutation or not. But thank you. Synonymous mutation or not, but it really depends on your ingest pipeline, the way that you're doing that.
Yeah, so I think we'd have to have like Sean or
Yeah.
somebody like that come and explain that stuff.
So we have a couple more minutes before we take our coffee break. Maybe time for one more
It's a
question?
really important area though, data modeling stuff. And so what UK Biobank is doing, what the all of us is doing, what the rare disease consortium is, all these, what's the right way to represent an individual's critical variants that we know about so far.
I don't have those. Ontology.
Any other last questions from the group? All right, how about we have a last round of applause for our group?
Take a break.